Silas Maths,
the best place to learn mathematics.
Hello friend, welcome back to class. Alright, like we said in our previous class, we're going to be continuing with the topic indicial equation. So we've been able to discuss laws of indices extensively. So if you've not gone to those classes, do well to go through them. So in today's class, we're going to be looking at indicial equation. Okay, so in solving a problem that has to do with indicial equation, we have to consider two cases. There are two cases that will play a role in solving this problem. Number one, that's case one, is this. When we have this equation, let's say we have a to the power of x equal to a to the power of y. So this simply states that whenever their bases are the same and we're having an equation like this, you just equate the powers. That is, cancel out this base and then x become equal to what? Y. Okay, when the bases are the same in this format, we equate their what? Powers. While the second case we need to consider, that's case 2, we need to consider is when their powers are the same. Let's take, for example, we have 2 to the power of x equal to a to the power of x. Now considering this one, now their powers are what? The same, so therefore we equate their base. We equate the base. So this simply means that 2 is equal to what? A, right? So we cancel, or we just equate their what? Equate the base for this case. Why? For this case, when the bases are the same, we equate their what? Powers. So that's what we're going to be considering while solving indicial equations. Okay, let's quickly take example. So I have this example. Find the value of x in the following. I have 1. All right, let's consider these two equations. Number 1, I have this. So we should find the value of x. So let's pick this first one. I have 4 raised to power 2x, or 4 exponent 2x equal to 8 exponent what? 2. Now, for me to solve this problem, I have to make sure that the bases are the same. So how do I express this equation to have the same base? So what I'm going to do is to ask myself a question. I can actually express 4 and 8, 2 raised to power a number. So the number that we multiply itself to give us 4 is what? 2. The same thing with this one. 2 times itself 3 times will give us what? 8. So that simply means that this becomes 2 to the power of 2 all to the power of what? 2x equal to 2 to the power of 3 all to the power of what? 2, where this is something as 4 and this is something as what? 8. So simplifying further, remember we apply the power law that states we multiply their powers. So this will multiply this. I have what? 2 to the power of 2x times 2 will give us what? 4x equal to this one. 2 times this will give me what? 2 to the power of what? 6. So at this point, their bases are not the same. So what we'll do is to equate the powers. All right, equate the powers. So we will now have 4x equal to what? 6. So in this case, for us to find the value of x, we divide both sides by the coefficient of what? X, and the coefficient of x here is 4. So we divide both sides by what? 4. 4 here, 4 here, so that x will be left alone. So we have x equal to 6 over 4. And 6 over 4 is something as what? 2 can divide. 2 into 6 is 3, and 2 into 4 is 2. So we have x equal to, expressing this in a mixed fraction, 2 into 3 is 1, remainder what? Is 1, remainder 1. So that will give me what? One whole number 1 over 2. So that is that for this one. we've been able to find the value of x. Then for number b, I have b 9 to the power of what, x plus 1 equal to 3 to the power of x plus 5. So the similar thing will take place here. We take a look at 9. 9 can be expressed in the multiple of 3. That is 3 times 3 will give us 9. That is to say, writing 9 in index form, 9 is something as 3 to the power of what, 2. If you recall, 9 is something as 3 to the power of 2. So I will say 3 to the power of 2 or to the power of what, x plus 1. This is 9 to the power of this. So that is equal to what, 3 to the power of what, x plus 5. So in simplifying further, we'll remember power law. These 2 multiply this here. So I'm going to have 3 to the power of what, 2 in bracket x plus 1 equal to 3 to the power of x plus 5. So to complete that, we can say that either we equate these powers from this point, or I can as well open this bracket from here. So let me see if I can use this space to solve that. Okay, so I have 3 to the power of, let's open this bracket, 2 times x will give me what, 2x. 2 times 1 will give us what, 2. So I have plus 2 equal to what, 3 to the power of what, x plus 5. Now at this point, their bases are the same. What do? We equate their what, powers. So equate the powers. We're going to have 2x plus 2 equal to x plus 5. So at this point, what do we do to find the value of x? We collect like terms. We collect what? Collect like terms. Right? So in collecting like terms, all the values that have x should cross over to one side, while those ones that are just single numbers should move over to the other side. So bringing x over to this side of the equation, I will have 2x. So this is a positive x. When positive crosses over the equality sign, the sign will, but when any number crosses over the equality sign, the sign it carries will change. So for this x is having a positive sign. So when it crosses over to the other side, the sign will become what, negative x. Okay, so negative x equal to 5. Then this 2 is positive 2. When it crosses over to the other side also, it becomes what, negative 2. All right, so we go ahead and simplify. 2x minus x will give me what, x, while 5 minus 2 will give me what, 3. So that is the value of what, x. So this is our answer. All right, so take a closer look at this. We'll simply apply this first case. All right, our aim is to make sure that the bases are the same. At the point where the bases are the same, we can go ahead and equate the powers and then solve the simple linear equation. All right, so let's see if we can take another example. Take a look at this. Copy this down. Give the video a pause and copy this down while we proceed. All right, let's consider this second example. We have 2 questions here to solve. Still applying, this is still on the initial equation. So let's have this number 1. I have 2 to the power of x minus 1 divided by 32 to the power of x equal to what, 8. Yes, so what do? We go ahead and then write this in the proper form. We're going to have 2 to the power of x minus 1 divided by 32 to the power of x equal to what, 8. So we can actually express 32 in form of a multiple of 2. That is 32 is equal to 2 times 2, 4 times 2, 8 times 2, 16 times 2, 30 what, 2. That is 1, 2, 3, 4, 5. So 32 can be expressed as 2 to the power of 5. That is 2 to the power of 5. So if that is the case, I'm going to have 2 to the power of x minus 1 all over what, 2 to the power of 5, or to the power of what, x, or to the power of x equal to 8 can be expressed as 2 to the power of 3. So if that is the case, we'll go ahead and simplify further. I have 2 to the power of x minus 1 all over the power to power law. This times this is going to give us 2 to the power of what, 5x equal to 2 to the power of 3. So we'll go ahead and apply the division law that states that when their bases are the same, we'll subtract their powers. So that will give us 2 to the power of x minus 1, then minus 5x, right? It's equal to what? 2 to the power of what? 3. So at this point, their bases are the same. We can go ahead and equate their powers. Okay, so equating their powers, or we can simplify further by saying x minus 5x is going to give me minus 4x. So I have 2 to the power of minus 4x minus 1 equal to 2 to the power of 3. So what do I do at this point? Equate their powers. Equate their powers. So when we do that, we have minus 4x minus 1 equal to what? 3 at this point when the bases are the same. So we go ahead and solve. Simplifying this, what do? We collect like terms. So for this one over here, we collect like terms. The one that doesn't have x should cross over. So collecting like terms, we have this. Collecting like terms. So we are going to have minus 4x will remain where it is. So minus 1 crosses over, it becomes what? Plus 1. So that will give us equal to 3 plus 1. Right? So I have minus 4x equal to what? 4. So divide both sides by what? Divide both sides by negative 4. That is the coefficient of x. Coefficient of x is negative 4. So I'm going to have minus 4x divided by minus 4 equal to 4 divided by what? Minus 4. Right? When we go ahead and simplify that, we're going to have this cancel out this, then x equal to 4 divided by minus 4 is going to give us what? Minus 1. So that is our answer for this. Right? This is the answer for number 1. Then let's quickly jump into number 2. You can give the video a pause and then copy this down. If you have any question, don't forget to drop it at the comment section. Alright, let's jump into number 2. Okay, I want to clean this side. Alright, let's take a look at number 2. We have 5 raised to power 2x times 25 raised to power x plus 1, all divided by 125 x plus 1 equal to 1. So let's go ahead. All these are multiples of 5. We can actually express 25 in form of 5 times 5, then 125 into 5 raised to power 3. So this will give us, this is equal to 5 raised to power what? 2x times, for 25 is something as 5 to the power of what? 2. Then we'll go ahead and raise it to power x plus 1 divided by 125 is something as 5 to the power of 3, or to the power of what? X plus 1 equal to 1. Now you will recall that any number to the power of 0 is equal to 1, right? Any number to the power of 0 is equal to 1. So we can say therefore 5 to the power of 0 is equal to 1. So we want to replace this one over here with 5 to the power of 0. So that will give us, let's simplify this further. We are going to have 5 to the power of 2x times, multiplying this, I'm going to have 5 to the power of 2 open bracket x plus 1 all over 5 3 open bracket x plus 1 equal to what? 5 to the power of what? 0. Yes. Now we are going to apply the multiplication law that states that when the bases are the same and they are multiplying, we add their powers. So this is going to give us 5 to the power of 2x plus 2 open bracket x plus 1, all right, dividing 5 to the power of, let's open this bracket. If we open this bracket, 3 times x will give me what? 3x. Then 3 times 1 will give me what? Plus 3. Equal to 5 to the power of what? 0. All right, so simplifying further, we are going to have this. We need to open this bracket. When you open this bracket, we are going to have 5 to the power of what? 2x plus 2 times this will give me 2x. Then 2 times 1 will give me what? Plus 1. Or dividing what? 5 to the power of what? 3x plus 3 equal to 5 to the power of what? 0. Now let's continue. We have to clean this side so that we'll be able to have space to solve the problem. Alright, to continue, you have to copy this down if you have not done so that I will clean this place while we continue solving the problem. Okay, let me clean this place. Alright, so still on that, we will say we have to express this in simplify for that. 2x plus 2x will give us 4x. So I'm going to have 5 to the power of 4x, then plus 1, okay, divided by what? 5 to the power of what? 3x plus 3 equal to 5 to the power of what? 0. Now at this point, we are going to apply the law of division that states that when their bases are the same and they're divided, we'll go ahead and subtract their what? Powers. So in doing that, I'm going to have 5 to the power of 4x plus 1, then minus the power of the denominator, which is what? 3x plus 3 equal to what? 5 to the power of 0. Now mind you what I did here, because this I'm having an equation or an expression, I have to put everything here in brackets because of this minus sign over here, because the minus sign is going to affect every single number in the bracket. So in opening that bracket now, I'm going to have 5 to the power of 4x plus 1 minus, opening here, I'm going to have minus 3x minus plus is going to give me minus 3, then equal to 5 to the power of what? 0. Then we have come to the point where we need to equate their powers, because at this point their bases are the same, so we'll go ahead and equate what? Their powers. So equate the powers. So we have 4x minus 3x will give us what? X. Then 1 minus 3 will give us what? 1 minus 3 will give us minus 2 equal to what? 0. So at this point, what we do is to collect like terms. So in collecting like terms now, these two have to cross over to the other side. So I'm going to have x equal to what? 2, because whenever negative crosses over to the other side of the equation, it becomes what? Positive. So that is our answer. Right? This is the answer to this problem. So you have to settle down and go through all the steps we have taken to arrive to this answer. If you have any question, do well to ask that at the comment section. So we're going to call it a pause for now. Thanks for joining. Okay, see you in our next class. Don't forget to subscribe if you have not, and also turn on the notification bell as well, so that whenever we drop a content like this, we will easily catch it up. Bye for now. See you in our next class.